Chapter 8: Computational Thinking. Learning Targets. What is computational thinking? Key components of computational thinking. Using computational thinking for programming. Importance of computational thinking. Simi was asked to organize a charity event for her school. At first, she felt the task was overwhelming and doubted whether she could manage it. After discussing her concerns with her mother, she was advised to break the entire planning into smaller, more manageable steps. Simi followed this advice by dividing the work into tasks like selecting the venue, inviting participants, organizing activities, arranging refreshments, and managing the budget. By handling each task one by one, Simi successfully organized the event, which was praised by everyone involved. How did Simi accomplish this task despite it being her first time organizing an event? She achieved this by using a technique called computational thinking. What is computational thinking? Computational thinking (CT) is a method of solving problems by breaking them down into smaller, more manageable parts. This process can be applied across various fields, not just computer science, and is valuable in everyday problem-solving situations. CT involves several key steps. Breaking a large, complex problem into smaller, easier-to-handle tasks. By addressing each part individually, the problem becomes more manageable. Identifying similarities or trends within the smaller tasks. Recognizing these patterns can help predict solutions and develop strategies for similar problems in the future. Focusing only on the most important details while ignoring unnecessary information. This helps simplify complex problems by removing distractions and concentrating on the essential components. Creating a step-by-step plan to solve the problem. These instructions can be reused for similar issues in the future, making the problem-solving process more efficient. Tech Info. Seymour Papert is recognized as the first person to use the term computational thinking. He was a mathematician and a co-founder of the Artificial Intelligence Lab at MIT. Key components of computational thinking. Computational thinking (CT) consists of 5 core components that aid in problem solving. 1. Analysis, understanding the problem by identifying its constraints and goals. This step helps clarify the issue and ensures you know exactly what needs to be solved. 2. Decomposition, breaking down large tasks or problems into smaller, more manageable parts. Each smaller component is tackled separately, making the overall problem easier to understand and solve. 3. Pattern recognition, recognizing trends, similarities, or repeated elements in the data or tasks. This helps predict future outcomes and develop strategies for solving similar problems. 4. Abstraction, focusing on the essential elements of the problem by filtering out unnecessary details. This allows for a clear focus on what truly matters. 5. Algorithm design, creating a clear step-by-step process for solving the problem. This plan can also be applied to similar problems, offering a consistent and effective approach to problem solving. Let us explore how computational thinking (CT) can be applied to solve a problem using Simi's example, as discussed on the previous page. We will break down how each component of CT helped Simi achieve her goal. Analyzing. Simi first needed to understand the problem and the objectives of the charity event. Goal: organize a successful charity event to raise funds for children in need. Constraints: budget limits, location, availability of volunteers, and time frame. By analyzing the situation, Simi defined the overall goal clearly and understood what was necessary to make the event a success while considering the available resources and limitations. Decomposition. Instead of viewing the entire charity event as one huge task, Simi broke it down into smaller, more manageable parts. This made the problem feel less overwhelming and more achievable. Some of the smaller tasks she focused on included finding a venue, researching suitable locations for the charity event, inviting volunteers, organizing a team to help run the event, fundraising ideas, planning how to raise funds, for example, auctions, donation boxes, or activities, publicity, creating posters and social media posts to spread awareness about the event, guest list and invitations, deciding who to invite and sending out invitations. By breaking the task into these smaller pieces, Simi could tackle each part step by step. Pattern recognition. As Simi worked through the different tasks, she began to notice patterns or similarities. For instance, organizing the venue was similar to organizing volunteers. Both required communication, scheduling, and planning. Recognizing these patterns helped her apply the same approach to multiple tasks. Pattern: both finding a venue and inviting volunteers involved coordination and scheduling. Prediction: if she could manage the venue and volunteers with clear communication and time management, the rest of the tasks, like publicity, would follow more smoothly. By recognizing these patterns, Simi was able to speed up her planning process and avoid reinventing the wheel. Abstraction. Simi used abstraction to focus on the most important details of the charity event. Instead of getting lost in the small details, like the choice of decorations or the exact color of the flyers, she focused on the bigger picture: fundraising, venue, and guest participation. Focusing on essentials, Simi concentrated on critical aspects such as fundraising goals, volunteer coordination, and publicity for the event. Excluding distractions, by not getting bogged down in less important details, such as the color scheme, she stayed focused on achieving the main objective. Abstraction helped Simi stay organized and ensured that she did not waste time on unnecessary tasks. Algorithm design. To ensure the charity event ran smoothly, Simi developed a detailed, step-by-step plan that covered every task and deadline. This algorithm helped her stay organized and ensured nothing was overlooked. Here is a simplified version of her approach. Step 1. Identify key roles. List roles such as coordinators, decorators, and fundraisers. Step 2. Reach out to volunteers. Invite volunteers via email or social media. Step 3. Assign tasks. Confirm volunteers and assign specific roles. Step 4. Brief volunteers. Hold a meeting to explain expectations and tasks. Step 5. Create a timeline. Set deadlines for each task and milestone. Step 6. Secure supplies. Gather decorations, food, and promotional materials. Step 7. Promote the event. Advertise using posters and social media. Step 8. Monitor progress. Check in regularly to ensure tasks are on track. Step 9. Coordinate on event day. Ensure volunteers are in place and tasks are completed. Step 10. Follow up. Thank volunteers and gather feedback to improve future events. This step-by-step approach helped Simi manage every aspect of the event, ensuring its success. Tech info. The term algorithm is often said to have originated from a 9th century Persian mathematician named Al-Khwarizmi, who is also known as the father of algebra. His groundbreaking work in mathematics, particularly in algebra and the development of algorithms, has had a lasting impact on both Eastern and Western science. Using computational thinking for programming. When developing computer programs, computational thinking helps you figure out exactly what steps the computer needs to take to solve a problem. This process enables you to break down the problem into manageable pieces and then translate these steps into a program using a suitable programming language. By applying computational thinking, you can create efficient and logical solutions that a computer can execute. Importance of computational thinking. Computational thinking helps solve complex problems and also develops important skills that are useful in both technology and everyday problem solving. Here is how computational thinking improves different abilities. Problem solving. Computational thinking equips us to solve problems logically by breaking them down into smaller, more manageable parts. It involves recognizing the problem's core issues and applying computational models to find solutions. This helps in evaluating whether a problem can be solved using computational methods and in specifying criteria for effective solutions. Perseverance. Computational thinking encourages persistence. Students and individuals learn to tackle problems without getting overwhelmed by their complexity. It teaches that every problem can be solved step by following a structured approach, making even the most challenging tasks achievable. Building algorithms. One of the key elements of computational thinking is constructing algorithms, clear, step-by-step instructions for solving a problem. By selecting appropriate algorithms, we can solve problems efficiently and apply the same methods to similar future problems. Building these reusable solutions fosters deeper understanding of how tasks can be automated. Debugging is a critical aspect of computational thinking and programming. It involves identifying errors in logic or the process and fixing them. Through feedback and evaluation, individuals learn how to improve their algorithms, strategies, and overall problem-solving approach, making the process more effective over time. Simulation. Computational thinking encourages the use of simulation, creating models to test and predict outcomes. Students learn to design test scenarios and decide which factors should be considered when developing their abstractions. This helps in making informed decisions about how to proceed with solving the problem. Socializing. Social aspects of computational thinking involve coordination, cooperation, and competition during problem solving. Working in teams or groups encourages brainstorming, strategy development, and shared evaluation of solutions. This collaboration enhances the overall quality of the problem-solving process and sets computational thinking apart from traditional individual programming tasks. Computational thinking is an essential skill that helps people solve complex problems, build algorithms, and improve through trial and error. Whether in programming, daily life, or collaborative projects, computational thinking fosters critical thinking, creativity, and perseverance, making it invaluable in modern education and problem solving. Wrap up. Computational thinking is a problem-solving approach. It breaks down problems into smaller parts, works on them individually, and combines them for a solution. Computational thinking involves problem-solving techniques, including logical reasoning, step-by-step solutions, and system design in the final stage. Analysis is the process of understanding the problem, considering the conditions and constraints, and defining the goals. Decomposition divides problems into smaller, manageable parts for better understanding. Pattern recognition identifies trends and similarities in data. Abstraction is the process of focusing on relevant details, ignoring unnecessary ones. Algorithm design creates step-by-step instructions to solve problems. Complex situations require more reasoning, skills, and experience. Computational thinking helps us determine what to instruct the computer to do and convert it into a program. Computational thinking fosters problem solving, perseverance, algorithm building, debugging, simulation, and socializing.